Hi, I'm Andy Temte, and welcome to the Saturday Morning Muse. Start your weekend with musings that are designed to improve financial literacy around the world. Today is September the 6th, 2025, and it is my 62nd birthday today. Yay! Anyway, last week we explored the fascinating history of compound interest, from Benjamin Franklin's 200-year experiment to the mathematical foundations laid by scholars like Edmund Halley and Leonhard Euler. We discovered how this powerful force helped shape nations, fund revolutions, and create fortunes, but also learned from cautionary tales like the Dutch tulip mania that exponential growth can work in both directions. So today we're moving from historical facts to practical application. It's time to understand the simple mathematics that makes compound interest so powerful and discover how you can harness this principle to build substantial wealth over your lifetime. So, at its core, compound interest follows a very straightforward principle. You earn returns not just on your original investment, but also on all the returns you've earned in previous periods. This creates a snowball effect where your money grows at an accelerating pace. So really the math we're talking about here is the math of exponents that you learned in basic algebra. The formula for compound interest is as follows. You get the future value of an investment after n years, where n is the number of years, equals the principal value, the amount of your original investment, multiplied by 1 plus the interest rate in decimal terms, and that whole thing is raised to the n power, where n represents the number of years. We call this the future value because we'll be discussing present value and future value concepts frequently in later episodes, so I want to introduce that terminology now. If you're watching this on YouTube or reading it in my simultaneously on my blog, we use the caret symbol as shorthand for raised to the power of. So if you're investing for 10 years, you'd raise 1 plus the interest rate to the 10th power. And if you're wondering where the caret symbol is on your keyboard, it's Shift 6 on most keyboards. So let's break it down with a simple example. Suppose that you invest $1,000 at a 7% annual return for 10 years. After year one, you'll have that $1,000 times 1.07 equals $1,070. After year two, you start with the $1,070, you multiply by the same 1.07%, and you'll get $1,145 at the end of year two. At the end of year three, you'll have $1,225, which is the $1,145 that you started the year with, times, again, 1.07. So, notice what's happening. In year one, you earn $70 in returns. But in year two, you earned $75 in returns, and that extra $5 came from earning returns on the previous year's $70 gain. By year three, you're earning returns on the $1,145 that's now available to you, not just your original $1,000. After 10 years, your $1,000 would grow to approximately $1,967. You almost doubled your money, but not through any complicated financial wizardry, but by simply earning returns on your returns. So, before calculators and smartphones, how did we do this? Well, investors used a simple trick called the Rule of 72 to estimate how long it takes money to double. This rule traces back to at least the 15th century, when Italian mathematician Luca Pacioli referenced it in his 1494 work on mathematics and accounting, giving merchants a quick way to make compound interest calculations without complicated math. So, here's how the Rule of 72 works. You take the number 72, you divide by the interest rate, and that gives you roughly the number of years to double your money. If you're earning that 7% that we talked about previously, your money doubles in approximately 10 years. The math is 72 divided by 7, which is 10.3. Remember, we didn't quite get to 2000. We only got to 1967, and that's why you're not doubling exactly in 10 years. It takes 10.3 years at 7% to double your money. Now, at 6%, if you're earning a little less, it's going to take longer. It's going to take 12 years. At 10%, it takes just over 7 years to double your money. This rule also works in reverse. If you want to double your money in 10 years, you need to earn approximately a 7.2% return annually. Now, I have to note that the rule of 72 isn't perfectly precise, but it's remarkably accurate for typical investment returns and gives you a quick way to visualize how compound growth affects your wealth over time. Now, let's talk about an example that might change how you think about some of your daily spending decisions. I often ask college students who are in their early 20s and recent graduates a simple question. How many times a day do you buy coffee at a coffee shop? So let's say you buy one fancy latte daily for $5. That's $35 a week, or about $1,825 a year. Most people think of this as a small daily expense. It's just $5, right? But what if instead of buying that latte, you invested $5 every single day in a Standard & Poor's 500 index fund? We'll talk about S&P 500 index funds later and how you can very easily set them up and make an automatic daily withdrawal out of your checking account. Now, the S&P 500 has delivered an average annual return of approximately 10% over the long term, including dividend reinvestments and adjusted for inflation. Now, here's where compound interest creates genuine magic. After 10 years, your daily $5 investment would be worth approximately $31,000. Not, you don't have confetti falling from the ceiling, but it's really substantial growth. After 20 years, you'll have around $117,000. So note the difference. You went from 10 years to 20 years, so you doubled the amount of time, but the investment was more than doubled. It went from $31,000 to $117,000. Now let's add another 10 years. After 30 years, you'd have approximately $348,000. And now let's add another 10 years. So we're now quadrupling that $31,000 that you had after 10 years, but it's worth nearly $978,000. So that daily $5 latte habit, if redirected to steady, consistent investment, could create a retirement fund worth nearly $1 million over a 40-year career. Even more remarkable, you would have contributed only $73,000 of your own money over those 40 years. And that's $5 times 365 days a year times 40 years. Compound interest generated the other $905,000. For the mathematically curious, I'm using daily compounding to arrive at these numbers. So our latte example illustrates compound interest's most crucial element, which is time and consistency. The difference between starting at age 25 versus starting at age 35 is dramatic, even if you invest the same amount. Somebody who starts investing that $825 annually, which is our daily latte money, at age 25 Well, you'll have approximately $970,000 at age 65. But somebody who waits until age 35 to start, losing only 10 years, will only have about $348,000 at retirement. So those 10 years cost the late starter $630,000 in retirement wealth. Time and consistency, not the amount invested necessarily, drives compound interest's power. This is why compound interest is particularly magical for people in their 20s. Every dollar you invest in your 20s has 4 decades or more to compound and grow. That same dollar invested in your 50s only has 10 or 15 years to work its magic. It's still important, but it's not nearly as impactful as if you are younger. So, just as compound interest can build wealth when you're saving and investing, it can destroy your financial future when you're borrowing at high interest rates. That same mathematical force that could turn your latte money into nearly $1 million works against you when you carry high credit card balances or take on other high interest debt. Next week, we're going to explore this darker side of compound interest and discover why understanding both faces of compound interest is absolutely essential for making smart financial decisions throughout your life. For now, the key takeaway is this: compound interest gives every young investor a superpower. Even modest amounts invested consistently over time can create substantial wealth. The question isn't whether you have enough money to invest, it's whether you're willing to redirect small daily expenses toward building your future financial freedom. Until next week, I wish you grace, dignity, and compassion. My name is Andy Tempty. This is the Saturday Morning Muse. You can find the show on all of the major streaming services as well as out on YouTube. Please like, subscribe, rate, and most importantly, share this public good with your friends, your family, your colleagues, and your neighbors. The show is produced by Nicholas Tempty, and we'll see you next time on the Saturday Morning Muse.